Hi everybody, this is a brief introduction to the new Lab 9A, which is a simplification, maybe just a little bit more interesting for this class. We're going to do just a little bit of work with lidar, create some contours, and then bring some DEM data into ArcScene and show you what a cool visualization tool that can be. It's a pretty light lab. I wanted to give you guys a break. I know this has been a tough semester, so I just thought I'd lighten things up this week. Okay, so first of all, here's where we're at. We're working on this little piece of lidar up here that's on the Bear River. This is Utah, northern Utah. Salt Lake City's down here. This is the Great Salt Lake. This is Cache Valley, Wasatch Front. If we zoom in here to Cache Valley, this is where Logan is. Here's Utah State University. We're right across the valley. The Wellsville Range, steepest, I think, in North America. For like as far as the footprint goes, they're the steepest mountains, I think, recorded in North America. Definitely not the world, but they're pretty steep. Anyway, here's our little piece of lidar that we're going to work with. The Bear River flows this way. There's a dam. Let's see if I can zoom in a little bit more and show you that, where we get Cutler Reservoir. You can kind of see how that's going to work here when we get our lidar to load. So here's our dam, and it's just a pretty cool little canyon feature that runs down here. So the first thing you're going to do is bring in your DEM, your lidar DEM. You're going to create a hillshade like this. Remember, you have to turn on the spatial analyst tools if you haven't run into this already. When this finishes drawing, you go to geoprocessing. No, you go to customize, extensions, and then check all these boxes. You should have done this already. Hit OK. You have to do that once per license, once per semester here on the Logan campus. So you'll need the spatial analyst tool to run the hillshade. That's what gives you this great terrain topographic layer. We can put the DEM semi-transparent on top of that just to get the lay of the elevation. I'm going to turn off my base map now. You can see it's a pretty cool feature with some historic terraces, a lot of floodplain action here and some paleo channels, but it's a pretty small little chunk just to conserve computer space. So you don't have to calculate slope, but I left them in here, and you don't have to calculate aspect from the DEM. You're just going to calculate the hillshade and contours. But I wanted to show you what these look like, and most importantly, show you what what the identify tool does. So I've got all the data in the map. The identify tool is something you're going to use in this lab. If we haven't used it already, I don't think so. But you click on it, and then you have to click on your map someplace to activate the tool, and it opens like this. So where I've clicked, I can set it to identify from the topmost, visible, selectable, or all layers. I'm going to set it for all for right now, and then I'm going to click again just to reset it. And it should populate a whole bunch of information here. So let me see if I can open this up a little bit. We've got the contour line, so it's trying to pull information from my vector data, but we'll skip that for now. For aspect, where I clicked, whatever cell that happened to be, the aspect was 314 degrees. So almost, if we go over to aspect, this is the direction the slope is facing. We are facing northwest, which makes perfect sense because I clicked about here, and this is a northwest facing slope. So that would make sense. The slope was 29. That's pretty low, but we're dealing with degrees, and it's possible that I just picked something that wasn't as steep as it looks like on this ledge. Let's see, this is the DEM, so I was at 1,354 meters of elevation, and then I've got a hillshade value of 254. So my question to you guys is, what do you think that means? Hillshade, we've got a range of values from 0 to 255. Remember, these are just the color of gray on this color ramp. They're bins. They just represent the color, basically. It doesn't tell us anything about slope, doesn't tell us anything about the elevation or the steepness or anything like that. It's just the color of gray, which is a proxy for this surface with a kind of a fake light source. Very good information coming from elevation, good information from slope, good information from aspect, worthless information coming from hillshade. Just a display tool. All right, so that's just a brief introduction to how the identify tool works. You're going to need that. When we go to calculate contours, it's just a tool, search for over here with using your search function. But you can label the contours, and I walk through this in the lab. Go away. Remember, it's a two-step process. You have to label features, and in the properties, you have to use the label tab. So you're going to do things a little differently this time and define classes of features and label each class differently. And you're going to use this query feature to write a statement. And I've got this in the instructions. I think the easiest way, there's definitely a better way, a more fluid way to do this, but I'm kind of, just manual grunt out. You can grunt out these queries. So I would just double click contour, equals, and then get unique values, and double click my. So you'll see this in the instructions. What we're trying to do is simplify it so that it's not labeling every single contour because it gets pretty messy. Just label 1300, 1400, 1500, 1600 meters. And to do that, we're just going to say label contour if it equals 1300, or label contour if it equals 1400, right? And you'll just double click to populate this query into here. So it's all in the instructions, but just so you know, we're going to label things a little differently than we normally do. And then the second thing we're going to do is ArcScene. It's a visualization tool. I never use it for analysis, but it does make some really great money shots of your data, and it's a great thing to do for reports and posters. So in your startup menu, which you can't see, go to All Programs and go to your ArcGIS folder, and we're going to open ArcScene 10.2. So click that guy and it'll open. Hang on, I'll move this over into the active window as soon as it opens. Doo-doo-doo. Okay, I do want a blank scene. I'm just going to hit OK, even though you can't see that, and I'll resize this. Uh-oh. Boop, boop. All right. Yes, I could have had this set up ahead of time, sorry. All right, so we're going to add data. In your data folder, there are 3 data sets. We've got snow basin DEM, a snow basin hillshade, and some roads for Weber County, which is where this is located. All right, so here's our stuff. We have this massive roads data set that covers the whole county. And then we have these DEM and hillshade. So the hillshade is drawing on top of the DEM, but you can see it's not complete. That's because they're competing in stacking order, drawing order. So one thing we can do is force our hillshade to draw based on the values in our DEM. So we right click on our hillshade and go into the properties. We can go to the base heights tab. We can force it to pull its elevation from a custom surface, which is our DEM. Does that make sense? I just dropped this guy down and picked the DEM instead of the hillshade, and I can hit OK. That's going to force the hillshade to pop up using the elevations from the DEM. So I can actually just turn the DEM off if I want to now. And I've got my hillshade. It acts a little bit more like Google Earth in that I can rotate it, I can see underneath it, just swivel it around. There's a couple other little tricks we can do. We can force the roads to draw the same way. Let's see, our base heights tab, force it to the custom surface. Oopsie. Pick the DEM. That gets our roads drawing on top. I'll make them a little bit bolder so you can see. Now they're drawing on top of my hillshade. We can also exaggerate the surface, not that we really need to around the snow basin area, but if we go into the properties of the data frame itself, scene layers, we can, vertical exaggeration, we can set this a little bit higher, and you can maybe just see how that affects things. So it just makes it pop up a little more. You can choose to do that or not. I have you do it in the instructions. You don't have to leave it that way for your screenshot. Basically, all you're doing in this lab is what I just did, and then grabbing a screenshot of this for your final submission. I just want to make sure that you guys are familiar with ArcScene, know what it's capable of, and just feel comfortable adding data to it and kind of knowing what some of the tricks are so that you can use this if you want to in some of your reports. Yeah, so that's it for the lab. Hopefully it's a little bit of a break for you guys. You deserve it. And if you have any questions, for sure let me know. If you have proceeded with Lab 9A, the old one about watershed delineation, have no fear. It's a great lab. If you have questions on it, let me know. If you want to bail on it and do this one instead, if you want to do them both, that's great. Just be in touch with me. And I wish you all well. Thanks.